Hi class. This video will be the first video we'll have in the kinematics series. And all kinematics is a way to describe motion. So every time I talk about kinematics, it portrays to the set of equations and the model for describing motion. Note how it does not explain why motion happens, it simply describes it. In the previous video, I mentioned that we can build all of mechanics from three fundamental quantities. The first one is length, the second one is time, and the third one is mass. So we can do all of kinematics with simply length and time. Mass will come into play a little later in the course. We will not worry a huge amount about how mass gets incorporated. And the first thing that we can build to describe a motion is called speed. And I think that speed is one of the more familiar terms in kinematics because it's something that everyone is familiar with. And everyone is familiar with this example because let's assume we had a car and this car is driving on a straight road. And this road has a speed limit. Everyone knows how to adhere by some speed limit. And we are in most speed limits for highways in the state of Wisconsin are 70 miles per hour. So now there's a lot hidden behind this number here, 70 miles per hour. This is a number that doesn't quite fit with the length, time, and mass quantities. And there's a very good reason for it. So let's take a car, and let's say that this car here is going to travel from this distance to this distance. And we want to call the distance traveled. We'll denote by a variable. We'll call that S. And that is the distance traveled. Now, if you had some clock here, it will take some time for this car to reach this point here, sometime later. And so you have some relationship for an object is traveling in a straight line. You have some relationship in between the distance traveled and how long it takes for this for this object to travel. So we can build a very useful quantity that we use to describe this motion in the future. So let's say that we want to know sometime in the future that has not happened yet. So sometime here. And we want to know with this clock at what time this object will reach this point. And this is called a prediction. And if you remember, to make a prediction, you need to have a model for this motion. And I'm going to build a model, and this model is going to be called speed. So we're going to build speed, and we're going to denote speed by the letter V, and speed equals to S, the distance traveled, divided by time. So this is our model for how this car or this object will travel in a straight line. Meaning that if I am to know the speed of this object, then I can tie the distance traveled with the time it takes to travel such a distance. Furthermore, if I know this distance, I do not need to follow this car to know how long it's going to take for in the future for it to reach a undetermined point right here. I'll be able to calculate and make a prediction. And for objects moving with constant or average speed per se, this is a very good estimation of those two variables. Okay, so let me give you an example, a very quick example. And I'm going to give you a quick example based on our speed limit diagram from earlier. So assume you have a straight line here, and you have a car here, and assume that this car will more or less travel at the speed limit. And the speed limit for this road is 70 miles per hour. Okay, great. 70 miles per hour. And what I have about a very special trip I have in mind. From point A to some point B, I know that these points are located 140 miles apart. And so you want to make a plan for this trip, and you know you cannot go any higher than 70 miles per hour, and you know that once you get in the highway, your speed is going to be more or less 70 miles per hour, and you Googled this path from point A to point B, and you found that it's 140 miles. And you want to be able to plan accordingly. So you want to predict how long it will take for you to get from point A to point B before you make the trip. So you are going to use the appropriate equation here, and you're going to identify what variables you have. So 140 miles here is the distance traveled, and you actually, in this case, have the velocity or the speed. You have the speed here is 70 miles per hour, and what you want to know is t equals to question mark. So the first thing you must do is you must write the statement of the problem in terms of an equation. That tells me that you understand that this is a kinematics equation, a kinematics problem. You say that speed equals to the distance traveled divided by time. And all you have to do now is solve for time. The best thing to do here is to multiply both sides of your equation by time divided by speed. So if you look on the left side, the speeds will go away and you're left with time. This is on the left side of the equation. And on the right side of the equation, you end up with the distance traveled divided by the speed. And once you get to this point, this is when you would then introduce the numbers. So this is 140 miles divided by 70 miles per hour. Okay, good. And this is the point where I would ask you to do some dimensional analysis. All dimensional analysis means is basically work out your unit. Don't assume that just because it's time and the SI unit for time in this course is seconds, that whatever 140 divided by 70, if you do not include these units, then you could easily get in the trap of saying that whatever number this is, you put a seconds in front of it. What I would advise you to do is to carry out this equality over here so that you can work it out. So 140 miles divided by, now miles per hour literally means 70 miles divided per hour. And something very interesting happens here is that miles over miles goes away, and 140 is also 14 divided by 7, which is 2. So what you end up having here is 1 over hour. and the best way to figure that this is just 1 hour, I will show you this trick. You can cut this division right here and say, okay, well, I can multiply this whole thing by 1, right? So I can multiply top and bottom by 1 hour. 1 over an hour divided multiplied by an hour, these hours go away, and all you have is 1 multiplied by an hour. So the only thing that's left is 2 hours. And that's your answer for this problem. So again, the main thing here is I would allow the variables here. I would allow these units to tell you what time of units, what units of time you're going to get as the end result. And note how time, any units of seconds, minutes, hours would count. And in this case, we got hours. Any calculations in this class, if you are suppose you were calculating for distance traveled, if you get any unit that is not a unit of length, you know you're in trouble. And so this is a very good habit to get into early on in the course, so that you catch mistakes early and you know what the appropriate units for every problem is. Okay, thank you very much, and I will talk to you all very soon.